Good afternoon, everybody. My name is Trupti, and today we will be talking about serverless applications and how we can secure them using microservices secure design. What are the things that we cannot secure using these design patterns, and for that, what do we need to do? And before I begin and tell you guys about myself, I would like to express gratitude to the entire crew of Seattle Bsides volunteers and organizers for giving this awesome opportunity in the middle of the pandemic. So thank you very much, guys. Now, a little bit about me. As I said, my name is Trupti. Currently, I'm working as a principal application security engineer at Illumio. It's been 13 years, but I started my career as a mobile game developer. And after doing game development for a couple of years, I realized my passion is security. When I'm not doing security, I like to travel and paint. And about 4 or 5 years back, I also got my yoga teacher's training certificate. So at Illumio, I not only do security, I also teach weekly meditation classes and breathing exercises. After this talk, if you want to get in touch with me, this is my contact information. So this is today's agenda. In next 1 hour, I will be covering what serverless applications are, what do you mean by serverless in the context of microservices, how they are evolved, and then how we can analyze some of the microservices design pattern from security perspective. And towards the end, I will be talking about some of the best practices for securing serverless applications and microservices. All right, so let's begin. Let's start with evolution and then try to understand what are the security pain points and how the overall role of security has changed with the evolution of microservices, serverless. Awesome. So as you can see on the left-hand side, there is a monolith application. If you remember, around 15 to 20 years back, the world was full of monolith giant applications, which contain a typical UI layer, then a big fat business logic layer, which was tightly coupled with the backend data layer. And then around 10, 12 years back, we saw the industry is moving more towards loosely coupled service-oriented architecture. But that was not sufficient. And that's exactly when we started seeing rise in microservices. So if you look at microservices, these are nothing but more loosely coupled service-oriented architecture. And lately, in last 5-6 years, we are seeing a rise in serverless applications. Some of the serverless applications are AWS Lambda, Google Functions, and we will be talking a lot about them today. But before we jump there, I just want to put things into perspective. Some of the applications which were built monolith, it takes a lot of time to break them down into a microservice-oriented architecture. For example, Netflix original application was a monolith application, and it took Netflix 2 years to break it down, split into a nice microservice-oriented architecture. And then it took them 7 years to complete that transition from the giant monolith to microservices. So as you can imagine, this is not something easy. What this transition really meant to Netflix was they were a traditional development company with 100 engineers producing a monolithic DVD rental application. And when they changed their architecture to microservice oriented, they divided themselves among multiple small teams responsible for end-to-end developments of hundreds of microservices that work together to stream the digital entertainment to millions of Netflix customers that we are enjoying pretty much every day in this pandemic. So when it comes to serverless is actually a deployment type of microservices only. Now the big question is, are serverless application going to replace monolith, service-oriented architecture, microservice architecture? Well, the answer is serverless applications have some serious limitations. So they definitely cannot replace microservices. What we will see in the industry is serverless and microservices will exist together. Now let's dive deep into what serverless applications really are. As the name suggests, in serverless, we don't have to manage the servers. Management of servers, patches, and whatnot, and other operational duties are performed by the cloud provider. Serverless applications are like these abstracted services, which are event driven, they are short-lived and stateless. The beauty of serverless application is they can scale up on demand or scale down on demand. And from business perspective, the best benefit is you pay as you use. And that's exactly what serverless applications are. Now let's take a deeper look into different attributes. From modularity perspective, we have seen that monoliths are very tightly coupled, whereas microservices are loosely coupled, just like serverless application. When it comes to inter-process communication, monolith applications uses heavyweight protocols like SOAP, but microservices use lightweight protocol like REST or gRPC. Serverless, we often see they use REST API. When it comes to handling data, we have seen with monolith applications, most of these applications use global data model or shared databases, whereas microservices, they use data models, smaller data models, or database per services. And in case of serverless, we all know the data is ephemeral. And we are going to talk a little bit more about it after a few slides. What are the threats associated with the data handled by serverless? Now let's talk about deployment model. Imagine what it takes to deploy a giant monolith application, lots and lots of time. Therefore, the overall speed of deployment is slow. Whereas microservices, these are small independent services, so the speed of deployment is quite fast. And when it comes to serverless, because majority of the operational tasks are taken care by cloud service provider, the deployment speed is even more faster. Now let's take a look at some of the microservices pain point. And I'm going to play a short video here.
Still not understanding this. Why is it so hard to display the birthday date on the settings page? Why can't we get this done this quarter?
Look, I'm sorry, we've been over this. It's the design of our back end. First, we have to call the bingo service. See, bingo knows everyone's name-o, so we get the user's ID out of there. Then from bingo, we can call Papaya and MBS to get that user ID and turn it into a user session token. We can validate those with OLNAP, and then, once we have that, we can finally pull the user's info down from Raccoon.
Yeah, but couldn't the Raccoon team basically just...
No, Raccoon isn't guaranteed to have that info. Before we do this, we have to go to Wingman to a query to see if the user is willing to take it to the next level or if they're just playing the field. Now, Wingman is cool, but he doesn't store any user info himself. He has to reach out to other user info provider services like RGS, Barbie Doll, Ringo 2, BLS. But how does it know what all the user provider services are? Well, for that, it has to go to Galactic, all-knowing user service provider aggregator. While Galactus has omniscient knowledge of all current user info providers, it doesn't have future sight or knowledge of past user info providers, so it expects a time range. To get all the current user info providers, we need to pass a time range with the current time and a time representing the end of the universe, which we get from EKS, our entropy chaos service. EKS is being deprecated at the end of the month for Omegastar, but Omegastar still doesn't support ISO timestamps like they said they would a month ago, so until Omegastar gets their fucking shit together, we're blocked. We can't get signed up for our use case, we can't use EKS, there's nothing we can do. So Galactus won't be able to find our new birthday boy provider, which means Wingman won't know how to talk to anybody, which means I won't be able to find true love.
All right. So that was a conversation between a developer who builds microservices for living and a product manager who wants him to do certain changes. And we can totally see how complicated it was for him to explain the dependency layers and how to introduce a small change. And I hope the product managers got it. This particular video is provided by Shazam and it's available on YouTube, and I highly recommend go check it out. Now, just the way the developer has these pain points around complexity, security people face exact same pain points. Microservice oriented architecture, which is a mix of different microservices and serverless application, it's highly complex. If you imagine a monolith application, because of tight coupling of different components and subcomponents, there was this implicit trust. And we humans are habituated. We try to repeat the patterns. In case of microservice oriented architecture, this implicit trust is very dangerous. It gets replaced by explicit trust, and every time checking these microservices before they talk to each other for explicit trust can be quite complex. Next thing is, in case of monolith, there is a static order of API. And if you look at this picture on the right-hand side, now that has changed into dynamic order of API, which is also quite tedious. When we have typical monolith application, we know the attack surface, what is getting exposed, what is not getting exposed. But in case of serverless, where the cloud provider have lot of leverage, sometimes the attack surface is quite unknown. We have to pay a special attention to define that attack surface. Most importantly, if you look at the traditional application security tooling or application security review mechanisms, that tooling is really not adequate for something that gets deployed like this with a level of complexity. Therefore, the traditional application security always doesn't work. And most importantly, the speed of deployment. With the help of serverless application infrastructure, the cloud service providers empowers developers with so much speed and easiness to deploy their innovation that if we go a traditional route, it becomes difficult for AppSec person to do his job. And as a result, traditional application security reviews are not possible. So those were some of the pain points. Now let's look at some of the implementation specific pain points. The funny thing is, OWASP vulnerabilities, which were published 20 years back, are still applicable to microservice-oriented applications and serverless applications. These are pretty much exact same vulnerabilities. What this means is, when the cloud service provider offers you the ability to write code fast and deploy fast, they don't necessarily offer you the ways to take care of these vulnerabilities by default. So as a developer, you have to pay attention towards all these vulnerabilities. And we are going to talk some of these vulnerabilities shortly in detail. Let's take a look at AWS Lambda. So those who know, AWS Lambda is a serverless function. Basically, you write the code, you zip it, and hand it over to the Lambda. We call that as a function. And then we configure it to integrate with number of events. For example, let's say a record change in DynamoDB, then do this. Now, when you're dealing with such serverless functions, all the debugging must be done through logging. There are not additional interfaces available to troubleshoot this type of functionality. And because of that, the testing is very limited. How can you use traditional tooling to test something that is so short-lived? If we are not careful about wiping the data securely after the function is executed, then there is a possibility of temporary data leakage. And most important thing is AWS Lambda security is enforced using IAM policies. And these IAM policies are not available to be secure by default. So if somebody makes a mistake, let's say use wildcard, then there is a chance that the overall security of AWS Lambda can be compromised. So we have to be extra careful. Just like any software, even AWS Lambda had security vulnerabilities. It was introduced in 2014, and so far 3 vulnerabilities have published. The most recent vulnerability was around code injection in their CLI tool called AWS Lambda, where a simple bound check was missing, and as a result, attacker can execute arbitrary OS command. So the point is, we can't rely on the security provided by cloud service provider. We have to make sure every aspect of the serverless application or function that we are using is secure. Now let's ask a question, why is that? And what's our role in this security as a developer or AppSec engineer? So if you carefully look at this shared security model provided by any cloud service provider, you will understand how the role of security has changed. Even in case of serverless functionality, the cloud service provider is responsible for taking care of operating system, virtual machine, storage, database, and security of the infrastructure part. They are responsible for deploying the operating system patches. But the complete responsibility of the code that we write, the data that the application handles, either at rest or in transit, the identity and access management, plus various cloud service configurations needed for your application to work properly, everything is your responsibility. And this is a big eye opener. This takes away the myth from us. Just because something is hosted by AWS or Google Cloud Provider or any other cloud service provider, that means that is secure and vetted. No. You know, as a developer, we need to take full responsibility of security. Now let's see how we can do that. In this section, I'm going to talk about some of the microservice design patterns. So design patterns are basically reusable autonomous service that we can use it again and again so that nothing becomes hindrance to our innovation. These design patterns basically allows us to accelerate application releases. So I have often seen my developers coming to us with these templates, and security team reviews those templates and make sure these templates are nicely vetted. And in this way, they don't need security teams review every single time they deploy these microservices. So that's the beauty of using design patterns. As such, there are a lot of design patterns out there. Just on the screen, you can see 26 design patterns. Obviously, I don't have time to go through each one of them. So I have selected few that I find are very interesting from security point of view. You will see in these design patterns, some of the security features are very well thought through. They come as out of box, and that makes it very easy for developer to configure them. All right, let's take a look at the first design pattern, API gateway. This is the most favorite design pattern. Now imagine your AWS Lambda service or Google function is part of service A or service B. In order to protect them, just take a look at how many security functionalities API gateway provides out of box. When we use API gateway, we can leverage it for authentication, API authorization. It also provides capabilities to prevent uh, denial of service attacks. It performs routing of requests. It has mechanisms to prevent layer 7 DOS attacks by providing us capabilities to define throttling limits, API rate limits. Basically, it does the overall load balancing for us. It makes sure all the endpoints are available on HTTPS, which is a big, big, big plus point. Moreover, you can do security and resiliency monitoring using your API gateway. So what I really like about this is there are tons and tons of good security functionality are inbuilt, and if we enable them, our applications are secure up to an extent. But again, this is not a silver bullet. Just because it provides all this nice, wonderful security functionality, that doesn't mean it is not vulnerable to attack. So there are some attacks that API gateway cannot provide. So this is something the developer of serverless applications has to keep in mind. Some of those vulnerable attacks are, let's say, layer 7 DDoS attack with counterfeit requests, or DDoS with cascading requests. Now, cascading requests are basically simple requests which, when reached to the backend, they generate many requests. And then it becomes difficult for backend microservices to manage it. And as a result, the service experiences denial of service. Next one is, if there are any implementation specific login or identity attack, let's say related to JWT token, then that is not something API gateway can take care. It's a design pattern, so it obviously has some security features, but there are definitely some attacks it cannot handle. For example, cross-site scripting and SQL injection. So it is the responsibility of the developer to ensure that these implementation specific attacks are taken care at code level. So let's take a look at one of the serverless function here. Let's say we have a serverless function which is responsible for performing login service. It accepts username, password, and returns a JWT token. Awesome, right? You will see these type of serverless functions are used for authentication of APIs or performing authorization for each request, which is basically needed between service to service communication. Now, if we get certain things right, for example, in a typical JWT web token, which consists of a header, cipher specification where we specify the crypto algorithm, then a payload, and then signature of the payload. If we get the cipher specification right, if I set it to none, then basically all the cryptographic security which is provided by the JWT token can be bypassed. Then the JWT specification provides a field called JTI. If this field is disabled by default, then our JWT implementation and the resulting serverless function is subject to a replay attack. And when you're not protecting your JWT token properly using right crypto or replay attack prevention, then information leakage can possible. So these are some small things which are extremely important. And the developer have to keep these things in mind for secure implementation of your serverless application. Now let's move on to a next design pattern. A circuit breaker design pattern basically is a software design pattern which is used in many microservice-based software development. It works the same way as how an electric circuit breaker works. When multiple services communicate with each other to serve the number of requests, there are many possibilities that the services are unavailable and are not responding. For example, this is a health check app, and it is connected to Redis cluster and DynamoDB and some external APIs. Let's say the Redis cluster is down. Now, what will happen is this particular microservice will inform a circuit breaker after a certain threshold is crossed. And as a result, the circuit will break. The circuit breaker will communicate with the external applications, which relies on smooth connectivity and communication with these internal services. And as a result, a failure is very gracefully communicated with all the intended parties. And this whole thing makes your application design very resilient. When the service is back and it reaches certain threshold, circuit breaker checks it again every few seconds, and once it's working fine, the whole thing works again. An appropriate message is communicated with the external application. So this particular pattern basically introduces resiliency in your architecture, and it is very important because failures do happen And it's the ability of the service to bounce back gracefully from failure, which is very important here. Now, usually circuit breakers are found in API gateways. Now, they are not bulletproof. What if somebody attacks the circuit breaker itself, right? You need to keep in mind how can we prevent attack on circuit breaker itself from resiliency perspective. So these are some interesting points that the security team members and developers need to talk out when they're designing serverless applications with microservices. Now let's move on to the next slide. Service mesh. Service mesh is actually infrastructure deployment of microservices. In a typical service mesh, proxies, these blue color boxes you see, yeah, these proxies are injected into each service which is deployed as a sidecar. Now, instead of calling services directly over the network, services then call their local sidecars. And these local sidecar proxies manage entire communication. The reason I like this particular microservice design because it uses mutual TLS to ensure the inter-service communication is completely encrypted. It also provides mechanisms to perform authentication and authorization of all the services. It provides access control policies to even enforce fine-grained access control. So it provides a lot of security features out of box. Now, again, this is also not bulletproof. Because of such complex infrastructure and design, this particular design pattern is prone to a lot of implementation specific security misconfiguration. So we have to watch out for those. All right, let's move on to log aggregator and design patterns. We all know that logs are extremely important from auditing and investigation perspective. Anytime there is failure or security incident, we need logs to do the investigation. So whenever you are building microservices, serverless function, always make sure you have this particular design pattern included in as part of your core applications. This particular design pattern allows collection of logs, which enables us to do real-time monitoring of anomalous patterns and events. You can also leverage this design pattern to perform automated logging. Now, just like other design patterns that we discussed, this one is also not bulletproof. There are some limitations. It is the responsibility of the architect to make sure correlation of logs happens correctly. Then as a developer, we want to make sure that we do not log any sensitive information in our logs, such as session tokens or authentication tokens or secrets. Because many times the speed at which we deploy these serverless applications, we don't have time to do double check. So we have to be mindful of in advance that we are not logging sensitive information. Third thing, if you are logging sensitive information or not, but if these logs get into the wrong hands, then game over. Because somebody can construct a lot of information from these logs. So it is very important to make sure the logs do not have any unauthorized access. All right, so that was about design patterns and what security functionality they provide out of box. And we discussed many implementation specific attacks and misconfigurations and settings that if we are not careful, then maybe the designs are not as effective as we think. In this section, let's talk about some of the best practices and understand what kind of scanning and tooling capabilities are out there that we can leverage to meet the speed of innovation and security assessment. So some of the best practices are, first of all, zero trust everything. What I mean by that, in monolith world, we were having this implicit trust because things were tightly coupled. In microservices world, zero trust your code. That means verify your code, verify applications that interact with each other, even verify the inter-process communication. What I mean by verify is make sure the authenticity and integrity is validated before you talk to them. In cloud, we have seen there are many encryption at rest services available, and this could be confusing to developers. Encryption at rest, encryption in transit, using server-side libraries or using client-side encryption. You can bring your own keys or you can leverage keys provided by cloud service provider, and this could be really confusing. I would say for encryption or any cryptography related design implementation decision, get in touch with your security team. Understand what option is right for you, what option is economic for you, because it varies from case to case. In some cases where you're implementing end-to-end encryption or message level encryption, it makes total sense to use client-side encryption with your own keys. But let's say your data is not so sensitive, but you care about unauthorized modification to that data, maybe it's okay to leverage the server side encryption provided by the cloud side provider. So it varies. There is really no one size fit all solution. So definitely get in touch with your security team, involve them early and find out what is the right encryption for you. Next best practices, whether you're writing monolith application, microservices, or serverless function, regardless, you need to pay special attention towards secure coding convention. Whatever programming language you are using, there are always security best coding practices available. Go read them and ensure you incorporate them as you write code. Then we already discussed the importance of logs. Not only generate logs, but analyze those logs, monitor those logs for any anomalous activity. And it would be nice if you can use some SIM stuff. Get in touch with your infrastructure security team for that. Next one is all these serverless function that you write from scratch. We all know there is heavy reliance on third-party libraries. And these third-party libraries always have CVEs. So stay on top of those CVEs. Use a good static source code composition scanner to find out the known CVEs and ensure that your code is secure, and a small CVE in the underlying library doesn't become the weakest link in your application. And I have said this numerous times, always involve your security team early. You will be amazed the kind of impact they can create just because you have involved them early. Because finding security issues right before production or in production, no fun. But when you involve them early, you can prevent so many vulnerabilities proactively. Now let's take a look at some of the security best practices more carefully. So secure communication is extremely important in microservices world. If you remember in monolith architecture, where there was a thick giant server-side application communicating with the client side, we used to have TLS connection. These TLS connections were not necessarily mutual, because again, there was some sort of implicit trust, and we used to establish these TLS connection to prevent man in the middle attack. But when it comes to microservice architecture or architecture which consists of native serverless functions or applications in a cloud environment, we can't trust anybody. So simple TLS connection doesn't work. We have to leverage mutual TLS, where both the parties are authenticated and validated. And the reason this is important, just take a look at on your right hand side, how many attacks were published in last 10 years related to TLS protocol implementation. And what does that tell you? Just like any other software, even security software is buggy. And that's why we have to stay on top of it. Do not use older TLS protocols because they have one of these vulnerabilities. In fact, I would say make your code, write your code in such a way that you introduce crypto agility. You know, we are on the verge of quantum cryptography, post-quantum cryptography attack. So the cryptography that you use in your application has to be post-quantum cryptography grade. So make sure you do not hardcore any ciphers, algorithm, key size, but make your code agile enough so that if you have to upgrade certain TLS protocol or ciphers, you can do that. TLS 1.3 is coming January 2022. So ensure that it's very easy in your crypto code to upgrade to TLS 1.3 when it comes. Last thing on this slide, pay attention to the key sizes and cipher algorithm types as well as their modes. And again, crypto is not something I would say anybody to do it. Get in touch with your security team and they will guide you. Let's move to the next one. The next best practice is about input and output validation. In microservice-oriented architecture with serverless application, I don't see those many cross-site scripting as I see blind cross-site scripting. What blind cross-site scripting really is, let me explain. Suppose your application deals with 4 more applications, and out of 4 applications, 3 applications have input validation and let's say output encoding. But there is a 4th application which is a legacy application, and let's say we did not get funding to change the monolith legacy application into a more modern microservice oriented architecture, and as a result it has vulnerability. So there is some data which is not validated, and when your application gets in touch with that data store, it gets affected by cross-site scripting. And when the cross-site scripting is not visible on the front end, but it exists, it is called blind cross-site scripting. So because of this complexity arise due to a hybrid mix of monolith microservices, which is a combination of legacy and new application, it is quite possible that old code is making your new code vulnerable. So therefore, very important, if something is in your application scope, make sure all the user entered input is thoroughly validated. Let's go to the next one. This one is about secure handling and storing of secrets. Usually I have seen in a monolith applications, secrets are stored in plain text files, environmental variables, or runtime configuration files, assuming that attacker can't get there and doesn't have access. But in microservices world, that's not true. Everything is out there, and because of the sheer complexity, just see how many different types of secrets we deal with. Secrets related to API service, each API service, secrets related to Artifactory, secrets related to your CI/CD environment, secrets related to testing or code management. All secrets must go in a weighted secret store. Cloud service provider provides tons and tons of options here. Always use the secret store provided by the cloud service provider and weighted by your security team. Super important. Now, let's take a look at how we can scale security. We have seen how difficult the architecture becomes, how complex it becomes, and therefore the speed at which developer wants to deploy the code is not the same speed at which security team can do all these reviews. That's exactly where tooling comes into the picture. Use your static code analysis tool integrated in your IDE itself, so that as soon as you write code, you can find out about those silly, security defects we make unknowingly, even before the commit. Then use, your application specific secure configuration checks at the time of build. And what this means is you can use some homegrown scanners as well, which are specific to your applications in case you don't find commercial tools. In testing phase, make sure you're performing your dynamic application security testing, or lately interactive application security testing is becoming very popular, which is agent-based testing, and it has access to both source code repository and dynamic execution of your application. So it uses both the sources to come up with more intelligent true positives and less false positives. So make sure all these tools are nicely integrated in your CI/CD pipeline. If you're using serverless applications as container, ensure that your templates go through security reviews. And there is lots and lots of free open source container security tools available. Based on your need, leverage those, make your basic template secure, and hand it over to your development teams. All right, so that was about security scanning in CI/CD. Now, as you all know, these tools are in their first or second generation. These tools do not have context, and that's why they generate false positive, or they do not provide adequate coverage to your microservices. In that case, what to do? I would say that write security unit test cases and automate them as part of your build pipeline. Uh, do it once and run it every time. Leverage your security team to do threat modeling of the new feature or function you're building. They will help you to come up with abuse cases and then write unit test cases to cover those abuse cases. Last, if you see a pattern of application security vulnerability, either related to the code or related to business logic, in that case probably commercial tool cannot help. So what really helps is build your own homegrown scanners to detect those vulnerabilities. All right, I know I have covered a lot of content, and now we are moving towards conclusion. So let me summarize. Today we discuss different architectures, how monolith architectures are different from microservice-oriented architecture, and then the rise of serverless function, and why it is important to zero trust them by default. Each time you leverage serverless application, it is extremely important to validate the authenticity of the serverless application to earn trust. Next is if you use weighted microservice design patterns provided by security team, and of course it's a collaborative work between security team, DevOps, and the development team. These weighted design patterns really help you to scale and foster security. Then we have seen that although the design patterns take care of majority of security functionalities, but they do not take care of some of the classic application security attacks. So know that these type of attacks are still possible, and think about how you can tackle them. You can either leverage commercial security tooling, which is available out there along with the open source tooling, or you can build your own homegrown security scanners. If you implement those scanners with your build pipeline, then the shift left of security transformation becomes super easy. And as I said earlier, tooling is not everything. It cannot guarantee you 100% security. Nobody can. But what really helps when you are in design and requirement gathering phase is threat modeling. Sit down with your development team, security team, and do threat modeling. In my experience, I have seen is threat modeling returns the highest number of vulnerabilities. It makes you think about abuse cases and all possible attacks and gives developer enough time to incorporate those in the basic design templates that you're building. And last, do not just focus on serverless applications or microservice, but take a look at a complete stack and ensure there is end-to-end security implemented. Now, these are some of the great references that I used to build this presentation. And yeah, these are great. Please take a look at these, and I will take questions now. Thank you, everybody.
Well, that was great, Trupti. Thanks. We've got one question so far in Discord. So let me take a quick look for you there. And it's, wouldn't sidecar proxies add overhead to the microservices?
Of course they are. That's why they are not one size fit all solution. Only when you need that type of architecture, one should leverage service mesh with sidecar proxies. Anything that you design must map to the business requirement as well. So yes, they are overhead, and that overhead actually introduces complexity.